Get through, so I may be a little more grumpy about shutting down side conversations. Kyler.
Yeah. Pay attention. Yeah, Kyler.
Yeah, Kyler. All right, so we need to define density curves. So this is the definition. A density curve is a curve that is always on or above the horizontal axis. The area under a density curve is always exactly 1. Density curves describe the overall pattern of a distribution. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that fall in that interval. So when it comes to distinguishing the median and mean of a density curve, by the way, I stole this picture from your textbook, so it is in there if you ever need to reference it. The median of a density curve is the equal areas point. That means the point that divides the area under the curve in half. Which makes sense if we think about the definition of median. That's the middle data point. So you have 50% below and 50% above. So it's the point that divides it in half. The mean of a density curve is the balance point. So at which the curve would balance if it was made of solid material. That one's always a little harder. I do have a visual if anybody wants to see it, but I don't have time for it right now. But I do have a visual to show you the balance point. The median and the mean are the same for a symmetric density curve. They both lie at the center of the curve. If you have a skewed curve, the mean is pulled away from the median in the direction of the tail. So just to reiterate that, we talked about that in the first unit, that the mean is non-resistant to outliers or skewness. So you're going to have some questions in your homework, possibly on your next unit test, that are going to ask you if a density curve is legitimate. And that means, does it hit all the definition requirements? So that's what we're looking at down here. So we're going to use this density curve over here to answer the following questions. A says, explain why it's legitimate. So to be a legitimate density curve, you have to have these two things met. That it's on or above the horizontal axis and the area is exactly 1. So if you look, it tells us right here that the total area under the curve is 1. So we met that part of the definition. Curve area equals 1. And then this is where you kind of have to use, I guess, your imagination. They don't explicitly put the horizontal axis, but because we have numbers labeled here, we can assume that this would go down to 0. Sorry, my line's not straight. I apologize. And that our curve is sitting above the x-axis or the horizontal axis. Yes?
What the other portion of the area is this point 1, 2?
We're going to get to that part in B. And I'm going to abbreviate horizontal axis as HA because I'm lazy. Part B says about what proportion of observations lie between 7 and 8. So that's what Alex was asking about. So notice that between 7 and 8, the color is darker, and that we have this line that points to that space and says the area is 0.12. So the proportion between 7 and 8 is 0.12. And what that means is that 0.12 of all observations or data points for this density curve fall between 7 and 8. Now, they don't always use the word proportion. Sometimes they'll ask for percent. It's the same question, except for 0.12 is a percent is what? 12. So if you see percent, it's not asking anything different. You would still use that piece of information. You would just say 12% of all observations. And then, of course, sometimes they'll ask you to state about what area, because, well, we're talking about the area under the curve. Nate?
So if they say proportion, we shouldn't give the percent. We should give them the decimal.
Yes. So proportion means decimals. Percent means change it to a percent. And yes, they do that on the AP exam. All right, so part C, I guess before I move on, any questions about part B? Part C says, excuse me, mark the appropriate location of the median. So the median, remember, is the point that's going to cut our curve in half. It's not going to be perfect because I'm not actually going to sit and measure the curve. I'm going to estimate where it is. So I personally, with these type of questions, like to work with pencil because if I mark it and then it looks uneven, I can erase it. But so the median means that I'm going to cut my curve in half as best I can. So it wouldn't be up here. I'm going to draw this just so we can see. If I put it at the highest point, it doesn't really cut it in half. There's a little more area to the left of that. So it is going to move to the left a little, but not a huge amount. I would say that that looks about half and half. Like I said, it's not a perfect thing. It does, even in the question, it says approximate. But you want to try and find the line that's going to put half of the curve on one side and half on the other. Questions?
Wait, since that doesn't have a numerical value, we put like greater than 8, or we just estimate it's
Just draw a line with an M. M stands for median. You don't have to put a number or anything. Sam,
Approximate exact.
say that again?
I thought approximate meant like exact.
No. Approximate means like,
Estimates.
In this case, yes. The other example I think of is in geometry. When you would like found the area of a circle, if it said exact, you left pi as pi. But if it said the approximate area, you used 3.14 for pi and got a decimally answer.
Get that out of there.
Any other questions? All right. Part D says now mark the approximate location of the mean. So again, approximate. This time we're doing the mean. And remember, if you have a skewed distribution, your mean gets pulled towards the tail. So we have some skewness to the left. So our mean is going to be pulled towards the left a little more. And the mean is supposed to be the balance point. So if I were to put it like on a ruler and try to balance it, it should balance, not tip one way or the other. So it's going to be a little more to the left than the median, but it's not going to be way down there.
Is that just because it's skewed?
Yes. And then I kind of already gave away the why do they have this relationship, because they're skewed. So skewed to the left is going to pull the mean to the left. Any questions before I flip my paper over? Alrighty. So, a few more definitions. These are definitions for the normal distribution and normal curve. So there are 4 characteristics about normal curves. It's a particularly important class of density curves. So a normal curve is still a density curve. It's just an important one. I wrote class, not curve, like an idiot, sorry. Curve. Normal curves describe normal distributions. And yes, you do capitalize normal in the middle of a sentence now when you're talking about a normal distribution or a normal curve, because they are that important. Normal curves are not normal at all. They're actually really special. The one thing that stays the same, though, is the area under the curve is still exactly 1. All normal curves have the same overall shape. They are symmetric, unimodal, and bell-shaped. So sometimes you probably have heard like a bell curve. Oh, the test scores follow a bell curve. They're talking about the normal distribution. A normal curve is completely described by giving the mean and its standard deviation. Now, we have special notation when we're working with a normal curve. We don't use x bar and s sub x for the mean and the standard deviation. When we're working with a normal curve, the mean, let's see, I'll write it up here, is used, we use mu, the Greek letter mu, an MU type thing. I see some kids who just do the M like that. I really don't care as long as I know what you're making, but mine look like that. It's kind of a sideways M. They don't start like the one part of the M's higher than the other part of the M. It also looks like a U, in my opinion, like a cursive U. It's mu. It's the Greek letter mu. So you'll see me write that. And then standard deviation, like I said, we don't use S sub x for normal curves. We use sigma, which is this one here, sigma, kind of circle with a line. This is sigma. You'll get used to making them, and yours may look a little different than mine. Sorry, my handwriting's so bad, it was on the edge of the paper. But we use mu for mean and sigma for standard deviation now. So when we draw a normal curve, we put a capital N to tell us that it's normal. And then in parentheses, we put the mean, comma, the standard deviation.
What's the end? No.
Yes, thank you. The capital N means normal. Then we have mu, the mean, sigma, the standard deviation. The mean is located at the center of this. I'm going to start over. The mean is located at the center of the symmetric curve and is the same as the median. So in a normal curve, our mean and our median are exactly the same. Standard deviation, your sigma, controls the spread of the normal curve. So the larger your sigma, the more spread out your data. The smaller the sigma, the closer together the data is. Can I move it up?
Okay, now
Well, now I'm taking a drink of water, so. All right. You can represent normal curves in quite a few ways, but they all have the same properties in common, and they all follow the same rule. And that rule is that in a normal distribution with mean mu and standard deviation sigma, that 68%, of the data or observations fall within one standard deviation of the mean.
So you want me to not gonna use the regular standard deviation.
I'll show you how to do a calculator problem in a couple minutes. Alex?
Will we ever get marked if we don't use this? If we just write sigma instead of the actual symbol for it?
If you wrote the word sigma,
Mm-hmm.
I've never had a kid ask me that. It's not a hard symbol.
I'm not good at drawing, so
It's simple for one.
you'd
Yeah.
be surprised.
Try it. Or, turn your paper sideways and make a B. It's pretty much what it is, right? I know, right?
Oh my god, it's...
All right. So, here is a template of a normal curve. Okay, so we're going to, sorry, I want to try and color coordinate here. So we have our normal curve, has mean mu, standard deviation sigma. At the center of your normal curve is your mean. So notice the hash marks down at the bottom. I'm going to take the one in the middle. That is my mean mu. 68% of the observations or the data fall within one standard deviation of the mean. So right here is one standard deviation above the mean, and right here is one standard deviation below the mean. Between those 2 points on the normal curve, 68% of my data is in between those 2 points. So I'm going to label this as mu plus 1 sigma. One standard deviation above the mean. This one here I'm going to label as mu, my mean, minus 1 sigma. So one standard deviation below. This? That one? Is that what you're asking? I'm going to turn it for you and zoom in because you're way in the back. My handwriting is pretty small. It says mu plus 1 sigma. The mean plus 1 standard deviation and the mean minus 1 standard deviation. That's a one above and one below.
You got triangle one.
No. But in years past, I didn't put the one there, and it kind of confused kids, so I just put the one. But no, you don't need the one. Ones can be invisible in math. Are we good?
Wait.
No.
What about the rest of the approximate?
Hold on. So we're just subtracting one standard deviation.
That's what we did there, yes. All right. Then, try and fit this. Nope, too zoomed in. There we go. Approximately 95% of the observations or data fall within 2 standard deviations of the mean. So looking at my template, here was 1 standard deviation above, so the next little hash mark would be 2 standard deviations above, and this one would be 2 below. So between those 2 points on my normal curve, I have 95% of the data. So I'm going to label those hash marks as mu plus 2 standard deviations and the mean minus 2 standard deviations.
Can we not go like to like the how about the other 2.5 on each side?
we're going to get there eventually. But that is a good point. I don't know if you guys heard Alex. He said, what about the other 2.5% on each side? So 95% is in the middle there between those two standard deviations. So what's happening with those 5% or 2.5 on each side, because it's symmetric? We will use this rule in a minute to answer some questions, and sometimes we'll use that area, sometimes we won't. Depends on what observations we're interested in. Hannah?
Isn't that the like statistical significance thing that you told us about?
It leads into it, yes. Yes. All right. And then the last one is that 99.7% of the observations fall within 3 standard deviations of the mean. So that's that hash mark way down there and way up there. So the mean plus 3 standard deviations. Mean minus 3 standard deviations. And let's see. I think I'm going to write it down here. Between those two blue is 99.7% of the data. Normal curves always follow this rule. No matter what kind of data you're looking at, whether you're looking at IQ scores or SAT scores or ACT scores. And the cool thing we're going to look at in a minute is no matter what the data is, we can always transform it into a normal curve so that we can compare them. Any questions before I flip my paper? I see a couple of you still writing, so I'll wait just a second. Calvin? Move it up or zoom in? Like that? So now we're going to use our rule, which, by the way, I always want to say it's called the golden rule, and I know that's not the golden rule. But every time I think of this rule, it's what comes to my head. So 68, 95, 99.7 rule. You might hear me say that, but like I said, I always hesitate because I want to say the golden rule. And it has nothing to do with golden rule. Yes, just that's the one that pops in my head. Are we good, Calvin? Okay. So we're going to use that rule to answer some questions now. This is my favorite example, I think, the whole entire year. And I'll see if anybody picks up on it. Yeah?
You use that rule for like everything?
Kinda. I mean, it never goes away. You should always remember it's 68, 95, 99.7. That's kind of what Hannah was getting at in psychology. My husband teaches it, so we switched, and I went and talked about the rule for the day, just because I know it better than him. Although Michelle told me I confused her, so it made me doubt myself. And told him he should stay in next year and do it. Because honestly, I don't know what you guys need to know for psychology. I felt like I gave extra information. All right. So she mentioned the statistical significance. We're not going to get into that this unit. It's in a couple units, but it builds upon this rule. So don't forget this rule. So the distribution at ITBS, Iowa Test of Basic Skills, vocabulary scores for 7th graders in Gary, Indiana, is normal with a mean of 6.84 and a standard deviation of 1.55. Notice how I read that. N tells me it's normal. The first number tells me the mean. The next number tells me the standard deviation. They're always given in that order. So if it's got a capital N, it's a normal curve or a normal distribution. Then I have my mean and my standard deviation. So now I can label my normal curve. At the center is my mean. So here at the center is 6.84. And I'm going to write sideways because otherwise all my numbers run into each other. So this is 6.84. This hash mark is one standard deviation above the mean. So that'd be 6.84 plus 1.55. Which gives me 8.39. This hash mark here is one standard deviation below, so the 6.84 minus a 1.55, which
What's the number about?
8.39. So the one below the mean is 5.29. The next hash mark is two standard deviations above. So 6.84 plus 2 times the 1.55. Two standard deviations, which would give me 9.94. This hash mark down here is 2 below, so 6.84 minus 2 times the 1.55, which is 3.74. And then I have 3 above and 3 below. So 11.49. And 2.19. Everybody good with how I got my labels? I'm going to turn my paper back. So we want to answer what percent of the ITBS vocabulary scores are less than 3.74. So it's asking for a percent, so my answer is going to be a percent. 3.74 is this one right here. So we want to know what percent is below that. So what percent is below in that little shaded area? Alex?
4.7?
I expected you to get it too, because you're the one that pointed out that if I'm looking at between these two, I have 95%. That means there's 5% on the two ends. Because our normal curve is symmetric, it breaks the 5% exactly in half. And that means I have 2.5% here. And I have 2.5% here. So what percent is below 3.74? 2.5%. And by the way, that picture up there is showing your work. So when it says show your work, if you draw a picture and you label it and shade things in, that's showing your work.
I got brain muddy. I thought it was 1.7 because it was 99. She just said the
Okay,
third.
so
The third one because there was a third dot. If you read it past, and I thought it was 1.7 minus the number.
check it out. It'd be easier if you look left and right. 95%. Alright, so this is 60
Shut up.
right here. 32 something. So it has enough a little bit on that, and then the same spot as that. Which is approximately 95%.
All right, part B.
So from
what percent of the scores are between 5.29 and 9.94? Let's see. 5.29. Can you guys see this color if I write with it?
Yeah.
That green over there? Okay. So 5.29 is right here, and 9.94 is right there. So we want to find this area here that I'm shading in with the bright green. Okay. So we know that between 5.29 and 8.39, we have 68% of our data. So what percent does that leave for the outside? 16 on each side, like Sam said, because 100 minus 68 would be 32, and 32 cut in half would be 16. So you have 16 over here, and you have 16 over here. So I know that from 8.39 to the end of my curve is 16%, but I only want that little space there. But I know from the previous problem that from 9.94 to the end is 2.5%. So what percent is between 8.39 and 9.94? Alex?
76.
No.
Oh. 13.75.
13.5. So I have 16% from 8.39 to the end. 9.94 to the end is 2.5%. So this space right here, let's make it this color. We take 16 minus the 2.5. So this right there, that green one, is 13.5%. So from 5.29 to 8.39 was 68%. 8.39 to 9.94 is 13.5%. So from those two, I'm going to take 68 to plus 13.5, which would be
81. So
percent.
So instead of dividing 16 by 2, I would just subtract it because that makes much more sense.
Okay. I don't know what you said. I couldn't hear it from here, but if you say it makes more sense, then we're good. All right. Any questions? You guys are going to try one on your own.
Oh, yeah. I'm actually
We're coloring in algebra 2. We're using lots of highlighter.
I don't think so. He added like color so much. I'm pretty sure Ew. Says, stop distracting my learning, Shannon. What?
It's not really hard.
So welcome.
Well, it's just a rule that they follow. 68% of the administrative position of the children. 71.95. Three of them are and because the cemetery is normal, at least 32% on the outside, and because the cemetery is about 16%. That statement, I was just stating it.
Oh, it's like the same thing.
Yeah, just in case some kids didn't pick up from the actual words,
Is that the,
the new.
okay, because that was like, that's completely stuff.
That's how the computer. It's like when you type, that's what it is. What do you want, Rob?
An eraser?
Yeah. It's not that hard once you learn how to do stuff. But they don't teach you guys, right?
I haven't even had a computer class. I've never. had a
Okay,
computer.
my son took that class. They don't teach you typing. Like when I took it, there was a thing you couldn't see, you couldn't even link back and see. But class was more about using Excel to like, I was so frustrated with that class. My son still doesn't know how to type correctly.
You have to like, I think there's like two different ways. One, you have your 4 fingers on the primary one.
Hold on, you gotta hand up.
Oh, I forgot.
How's that?
We're going towards that. I just say use the backup.
You'll be the 6%.
Can you hit that high note?
Yeah.
No, you can't. Zach can be the
Yes,
routine.
that is going to
You can be the rapper.
Whatever that number is.
You know how to be the rapper and like.
I'll do the scope. Like that one kid.
Yeah.
I didn't get that because I thought it was 95
Summer.
I just watched it the other day.
You
just realized that?
Yeah, I never.
You're a little slow.
I never watched that.
She was like the bossy manager.
Yeah, I never watched that.
never happened.
Hey.
That
is
fact.
I looked there, you
look back
As long as you're
Oh,
being
yeah.
I never watched it.
It's kind of a weird way that I wasn't.
6 points.
Well,
before you go there, from teaching people.
What fighting actors are between the point
Yeah, you're right.
193?
Oh, my bad.
Oh, no, sorry, not me. Sorry.
Yeah. You know that's what I'm
Yeah.
saying.
Sorry, I haven't done sync yet, so.
The second one is 81.5%.
No, I didn't realize
So we have 60%. Yes.
What?
How do you find out what that is?
Hello.
I thought confused.
Never seen this video?
No, I don't never even heard of it.
What percent rates on this?
Hello.
Okay, Yeah, what's 2% of the whole curve? So that's the middle.
I mean, I was getting to it.
Okay, now the symmetry.
And that very
tells
first
us
thing is like that's
that
just added, and then be like your south plus like
Okay,
that.
now 1% is a little bit.
Got me.
You might want to get this.
Yeah, that is good.
It's a job.
Usually got headaches.
I mean, I'm gonna.
You know who man is? Police officer.
Yeah,
That's solid.
that man is a stud.
You still have the.
That dude looked like the one officer.
Crush the bottom.
Yeah, that's exactly what I thought.
Yeah, you can't go.
Yeah.
Dude, that's just taking that percentage. That dude wants, that means instead of he does like percentage starting.
He does
Yeah,
like
that's
guns
the whole
also.
idea.
Yeah, like,
One guy does guns.
Be able to do
Yeah, also getting
it.
something.
Probably not.
All right, quiet down, please.
I've never seen such a
Yeah.
He is sitting. As long as Amelia can see, we're good. All right. All right. What percent of the batting averages are greater than 0.329? 2.5%. Don't forget your labels. And then what percent are between 0.193 and 0.295? And yes, I know you guys got angry when you saw it was the same answers, but I had you find different parts of the curves. So it kind of reinforces that symmetry idea. Can I flip?
Yes. No.
Backflip?
I wish I could backflip. That would be so cool, but I can't.
I'll teach you.
I'm like old, like my back hurts right now just from like sleeping funny. You think I can do a backflip? All right.
Yeah, don't you want to run?
I honestly think it was my dog, because my dog is slow. And so I've been running like this for 2 days.
My
My dog literally will sit down in the middle of a run and like not
My
move.
dog will do that too. Like, she'll be like, I'm done. I don't want to do it anymore. And then we have to walk for a little bit.
Oh no, see, I just let go of the leash because it's 5 a.m. and waits out. I'm like,
I
whatever.
would feel
If she of course touches
so
up,
yeah.
and it's like you obviously have energy, but I've been running like this, and I think that's
You will?
Is your dog like leash trained? Like, can you have it on top of him? So, like, when you get away,
no. Because if she sees another dog,
He's gonna sleep that.
so unfortunately, no.
I got the checks on the game.
All right. Standard normal distribution. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. Mean of 0, standard deviation of 1.
It's literally the same.
Oh, it is.
So we have 0 at the center. Then we have a positive 1 here and a negative 1 there. Then we have our positive 2 and our negative 2. And a positive 3 and a negative 3. So no matter what our variable is, you can always take the distribution and turn it into the standard normal distribution by changing all your data points into z-scores. So Remember I told you that this process right here of finding a z-score was called standardizing? So when you find z-scores, if you do it for the whole distribution, you change your distribution into the standard normal distribution with a mean of 0 at the center, and then your standard deviation is just 1.
What?
So I'm trying to think of a simple set of data. If I were to measure all your heights, and let's say we had an average height in here, we're measuring it in inches. Let's say the average height in here was 5'8", so 68 inches. Yeah, I gave you guys a lot of height, okay? And the standard deviation was, I don't know, let's go with 4 inches, just so it's pretty numbers, okay? So if I took every piece of data, if I took Michelle's height and I subtracted the mean and I divided by the standard deviation, it would turn into a z-score, which remember we learned those at the end of last week. And we talked about how to interpret them. So how tall are you? 5'3". So she's 63 inches tall. So if I wanted to find the z-score for Michelle, I would take her height, 63 inches, minus the mean, and divide by the standard deviation, which would be -5/4, so a -1.25. So she is 1.25 standard deviations below the mean. So she would fall on the standard normal curve of our class height right there. So I can take any distribution, whether it's class height or if I took, I don't know, our shoe size and found the average and the standard deviation, I can turn any distribution into this when I find z-scores for everybody. Did that clarify, Sam?
Yeah.
Okay. Any other questions? Hannah?
On like tests and stuff, will the mean and standard deviation be present so we can like plug in other stuff to create a z-score?
Unless I'm asking you to find one of them. Remember we did a couple of those that lesson where I said here's the z-score and here's the mean and the observation, find the standard deviation. So there'll always be at least 3 of the 4 parts present. Okay. Any other questions? All right. So in a standard normal distribution, the 68, 95, 99.7 rule tells us that 68% fall between a z-score of -1 and a z-score of +1. Right, that just tells us that, oops, should be working with the same colors, that between a -1 z-score and a +1 z-score, one standard deviation above and below the mean, that's 68% of our data. We could then use that to say that 95% fall between z being -2 and +2. We can use that rule. However, there's lots of times where we don't just want to know one perfect standard deviation above or below, or 2 or 3. We want to know, and this is really funny that it's z equals -1.25 because that's what I used and got for you. So sometimes we don't want perfect z-scores, perfect whole numbers. So there's another way that we can find answers that won't be just perfectly one standard deviation or 2 or 3 above or below the mean. We need our calculators for this. So does anybody need to borrow a graphing calculator before I get into this? Sam? Anybody else? Ethan, do you have your graphing calculator?
Yeah, I have it right here.
Hayden, you have it?
Hey, why don't you?
Right. All right, everybody ready? We focused? All right, so if we want to find the proportion of observations from the standard normal distribution that are less than 0.81. So first thing that you want to do, you want to sketch a picture. Yes, get used to sketching a picture. You may think it's tedious and pointless, but if you plan on passing the AP exam, you better have the picture, otherwise they don't give you credit. Because otherwise they think you just memorize buttons on a calculator to press, which, let's be honest, you are doing, but the picture shows why you press those buttons and helps you with the conceptual understanding. So pictures are important. So we're going to draw our standard normal curve, because we're working with the standard normal distribution. Your curves will get better as the year goes on. They're never going to be perfect, and that's okay. That's why we put the notation next to it that it's a normal curve with a mean of 0 and a standard deviation of 1. Because as ugly as my normal curve looks, that's going to tell whoever's grading your exam that it's a normal curve. So then we're going to put our labels down, 0 at the center, 1 standard deviation above, 2 above, 3 above, 1 below, 2 below, and 3 below. Now the question is asking to find the proportion, so my answer is going to be a decimal this time, that are less than 0.81. So 0.81 I'd estimate is like here-ish. Again, it's not going to be perfect because you don't have all those little hash marks. But so here's 0.81. I want to find the proportion less than. So I'm going to shade everything that is less than 0.81, so to the left. And then we let the calculator do the work for us. So, let's see. I'm going to walk you through it, then I'll write down the keystrokes so that you can copy them down if you need to, okay? So, we want to be in the home screen. You don't want to be in a graph or y equals, then it confuses the calculator. So you're going to hit second bars, which is right down below the arrows. And you should come to this menu. Second bars. Right here. Blue one, then the bars. Right next to clear. We good?
I'm learning so much about it.
I know, right? It does so much stuff. It even does calculus for you, but we don't teach you that.
Wait, how did you do it?
Hold up.
How can you do it without a calculator?
Do this without a calculator? It's in the back of your book, but it's really old school. I do have a note down at the bottom. Your textbook will reference Table A. It'll say, use Table A to do this. That's how we did it back before these things were invented.
Yeah.
Sure.
Yes.
But use your calculator. It's much easier. But Table A is back here at the back. There's a bunch of tables back here. Table A, and it's a list. And you have to go through and find the correct values. And if it's less than, table A works. If it's greater than, you have to do some math because it only gives you the values less than. But the calculator does less than and greater than, so just use the calculator. All right, so we're at this menu, and we're going to use normal CDF. So the first option is PDF. We want number 2, normal CDF.
What's the last problem?
Maybe, and I'm usually not this teacher, but stop the side conversations and you guys wouldn't be so far behind. You have not been. The 3 of you have been talking quite a bit, and I just keep going. I said that at the beginning. I have a lot to get through. I'm not going to be nice about it. I said that. All right, normal CDF. If you have an older calculator, it is going to just put it into the home screen for you. Newer calculators ask you the questions. This one? Just second bars and then number 2. And it should put it into the home screen for you. It's going to ask for the lower, the upper, the mean, and the median. Mean and the standard deviation. Okay? So even though it doesn't ask you for it here, that's what it wants. It wants the lower, the upper, then the mean, and the standard deviation. If we look at our picture, and this is why the picture is important, there is no lower bound. We're going on forever. Even though the curve ends, it could keep going forever and ever and ever, and I could have a data piece that is like 10 standard deviations below the mean. Okay? So you use a really small number, which if you notice, my calculator just put in there for me. It said -1 to the 99. That's scientific notation for a really small number. It has 99 zeros in front of the 1, okay, after a decimal. It's a really small number. You can leave that in there, or you can choose to put in a really small number like, I don't know, -100,000. It should work. Okay, if we were going the other way and we had no bound at the upper, you would use a really big number, like a positive 1 with the E99, or you could use a positive 100,000. Okay, just a really big number, a really small number, depending on if you have no lower bound or upper bound. Then our upper bound is the 0.81. That's where my shading stops. So I'm going to put 0.81 in here. We're working with the standard normal distribution, which is 0 and 1. So my mean is 0, standard deviation is 1. Mine already put that in there, so I don't have to change anything. Then I'm going to go down to paste, and it pastes it into the home screen for me. Okay? Then you guys, if you have a newer one, all you do is hit enter and it gives you an answer. Okay? That's the proportion of observations that fall in that shaded area. Those of you with the older calculators where you have to type it all in, first of all, please use the negative, not the minus button. It will confuse the calculator. So we're going to hit -1, and then if you want to do the scientific notation with the E, that is second comma, and it'll give you the E. Do not use alpha and then hit sign. Those are not the same E. Okay? Second comma, and then we're going to put 99 in there. Then we have to put the commas in for the calculator, so put a comma, and then our upper bound is 0.81, comma, my mean, comma, standard deviation. And then we're going to close the parentheses. I honestly don't think closing the parentheses really matters, but it's just a habit. And then if I hit enter, notice I get the same answer, just newer calculators prompt you for the information. The older ones, you have to type it in. We good? Zach?
So it's lower, upper.
Yeah, I'm gonna write it on our paper for us. So you wanna use normal CDF. And it's gonna ask for the lower bound, the upper bound, your mean, and your standard deviation. To get to normal CDF, that's the second bars, and you want to choose number 2. So, like I was saying with the picture, if you want full credit on the AP exam, you have to put a picture, okay? If you want full credit on the AP exam, you have to put the picture, and you have to put what you put in the calculator. Let's see, I'll use this color. So you would actually have to write normal CDF, and then we use -1 e to the 99, 0.81, 0, and 1. So I have my picture, I have what I put in the calculator, and then I would get full credit for this type of question. And the answer was 0.7910. The reason I go to 4 decimals is because if you use the old school way, table A, it goes to 4 decimals. Alex?
Wouldn't that be like a percentage of it?
It asks for the proportion. So I want to give it as a decimal. If it asks for percent, I put my answer as percent.
Which is just like 79.
It would be 79.1%, yes. Which, this one, I changed the wording because I want you to get used to both. So the next question is find the percent of the observations from the standard normal distribution that are less than 1.21.
Is that your turn?
No, I was going to do it, but then I realized that we had like 2 minutes left, so I wanted to see what I wasn't getting to. And I'm going to tell you skip 51 and 52 on your homework. Okay? Skip 51 and 52, because I haven't talked about those yet.
Can we complete the
No, you don't need to. It was just more practice and normal CDF.